Welcome to the Golf Improvement Podcast, episode 71.
Welcome to the podcast for golf lovers and enthusiasts who are looking to take their games to new heights. Dedicated to custom club fitting, short game improvement, and effective practice to improve your golf game. This is the Golf Improvement Podcast with your host, Tony Wright.
Hello, this is Tony Wright from Game Improvement Golf in Oak Ridge, Tennessee, with the Golf Improvement Podcast, dedicated to bringing you useful information on custom club fitting, short game improvement, and effective practice techniques to take your game to new heights. While I have to tell the truth, I don't always go back and listen to every interview again right after I record it, but not this time. I was really fascinated to get to talk to and listen to Jeff Sheets and hear him talk about driver head design. And there were a lot of things he said I was surprised at, and in addition, I learned a lot of things that I didn't know. So I'm excited to bring both to golfers and club fitters this terrific interview with Jeff Sheets from Jeff Sheets Golf. Hello, this is Tony Wright with the Golf Improvement Podcast. We're doing something a little bit different today, and I'm excited to get to talk with Jeff Sheets from Jeff Sheets Golf. You'll see information about him in the show notes in terms of a link to his website. But he's worked with more than 60 major golf major winners and 24 Golf Hall of Famers on their most important tools, their golf clubs. And in his website, it says he has more than 20 patents and over 500 club head designs. So this is, I hope, the start of more than one podcast, but we're going to talk about driver head design. And, you know, right now, this is the environment of the latest and greatest are out there, right? I mean, around this time, everybody says their new driver is terrific and wonderful, and not that they aren't, but some of the things golfers and club fitters might want to know about driver design. So, Jeff, thanks for doing this with me today. I appreciate it.
My pleasure, Tony.
Well, I looked on your site, and you talked about, somewhere around 1988 or so, you kind of got started in this area. But maybe talk a little bit about your story, how you first became interested in designing club heads, and maybe a little bit about some of the important things you had to learn to be good at this.
Well, my path to club design really began working out on the PGA Tour. And I'd worked in the equipment trailers, fitting equipment to first from the shaft end of the business and then from the head end of the business, working a couple of different trailers. And through the process of catering to the tour guys, there eventually came a time where a player would come in and say, "Can you grind on my wedge here? I want some heel relief out so I can lay it open more easily." And someone else would come in and say, "Can you hit the grinding belt here and there?" And it eventually evolved into a point where actually the first player was Bruce Devlin.
Oh, yeah, I remember him. Yeah.
And he had a full set of irons that he said, "This company will pay me pretty well to play these, but I really don't like the way they look. So can we alter the grind on them?" And back then, I was working in a shaft trailer. I had a 1x42-inch grinding belt used for braiding shaft tips.
Yeah.
And Devil and I sat there, him looking over my shoulder, as I sit there and reshaped that entire set of heads. And about 2 weeks later, another player came in and said, "Hey, can you do the same thing with my stuff that you did with Devil's?" And so that got me into my first insight onto taking a club head and looking at it differently than the way that it's presented to you. And I would say that was probably the seed that was planted in having an interest in shaping, designing, and ultimately, developing golf club heads.
Yeah, very interesting. It's been a long time since I've heard the name Bruce Devlin, right? He was quite a player.
I just had lunch a few days ago, actually last month. But
really?
Yeah, he's still up and moving about.
Well, as I said, we want to focus, primarily today on driver head design. Can you talk a little bit as a, sort of a start to finish, maybe a little summary in a way, but, sort of what's involved in the design, prototyping, and final creation of a new driver head, as you have done it?
You don't begin the design process without an idea of where you want to arrive at. And so to just develop a driver for the sake of developing a driver is it's really a waste of time and energy if you don't really lack the vision of what you want that driver to do. Mm-hmm. Everybody naturally knows you want to hit it as far and as straight as you possibly can. So those without saying are two of the design requirements that need to go into what needs to be engineered into the driver. But when a company will come to me and state, yep, we want to do a driver project, we want to hire you to go ahead and get this made for us, it immediately turns into an interview on what does he want it to do, who is your market target, what is your price point target in production and at retail, along with are there existing patents or patents that you have applied for that need to be bundled into this. And so there's quite a bit of things you got to look at before you move into the actual design of the driver. And it all begins with that. It's like fitting someone. You spend the more time you spend in your player fitting interview, the quicker you can get to the conclusion you're out there doing the fitting. And so the same is true with driver design and actually all product design for golf equipment. What we'll arrive at is essentially a target on certain criteria for the driver before I then move into working on even what it will look like. And sometimes that's all a person comes to me with is, I want a driver that emulates this or has this certain look, and they hadn't thought out the performance attributes and construction methods and many other things that eventually they have to be faced and make decisions on. But once we have an action to take on what to do with the driver design, I personally work very old school. I'm not part of the current generation of product development person. I'm back there with the Scotty Camerons and the Vokeys, and these are all the guys that I cut my teeth with.
You probably don't have a 3D printer that you're using to, or maybe
I
you
do have 3D.
Well,
yeah,
there you go.
I have a 3D printer when I built myself. But when it comes to starting with the shape of a club head, I will begin by modeling it by hand.
Okay.
And in the case of modeling a driver by hand, I have numerous molds from which I've developed over the years that I call so-called generic shapes. And I'll use a two-part resin system that I'll inject to them. And that gives me basically my block to sculpt from, as a sculptor would work. And before I remove any material and start shaping that block, I already know what the loft is going to be. I know what the face progression is going to be. I know what the volume is going to be, what the breadth and heel to toe measurements, and all of those have already been determined. And then I'll go ahead and start sculpting to that shape, and ultimately have what I'll call a plain version of what the client is looking for. It has all of the specifications in there, but what it doesn't have are all the little cutaways and screw ports and any other embellishments that give a golf club, whether it be a driver, fairway wood, or iron, its unique presentation. And sometimes I'm working with the client up front, and we have that complete physical presentation already determined 2D, or sometimes they want to go along for the ride and will give me direction on the general presentation that they're looking for. But once we arrive at that and have it sculpted and have all the indications, correct bulge and roll, hosel lengths, everything, from that point, I'm ready to move on to the tooling process. And I work directly with the tooling departments of various factories around the world. Quite often they'll take that part along with my blueprints and technical drawings, which go all the way down to the final cosmetic detail. And quite often they'll laser scan that part and create a 3D CAD file from which they go to tooling with. Other times, it depends on the factory. They'll go ahead and create a copper master based off of that shape, just essentially duplicate it. And once you get to the tooling, you've got your general shaping ready to go in an external form, but it's really what you do on the interior of that club head that's really going to make the performance shine or be a complete failure. And everything that occurs from the internal portion of it, which is basically if you're casting the head, you've got a core structure that's in that tooling and the wax is injected all around in the manufacturing process. Varying the wall thicknesses of that club head, adding ribs and reinforcement structures to alter sound and vibration, ensuring that the face has thicknesses that are optimized for that body, for the club head speed of the golfers that you anticipate are going to be using this, and for the type of golfer. If it's going to be a game forgivement type product versus something that is going to be a tour player type product, there's variations that I'll have in regards to the rear side of the face and the variable face thickness, how that's displaced, so that you either have something that's a lot more forgiving across the face, or you have something that's going to be quite a bit hotter and straighter if there's just very small mishits. All that needs to be taken into account, and that's all done in the tooling stage. And also, prior to the tooling, when you do have your 3D CAD of it, I've been doing this for so many years that I can pretty much go in there and know where the walls can be thinned out and still have great durability, where mass can be concentrated to shift the center of gravity, the direction that you want it. But you need to get your tooling finalized, optimized, and from there you have your first engineering samples, which you always keep your fingers crossed. They're going to be pretty darn good.
Yeah. So I'm guessing, every once in a while probably somebody says, Jeff, are you crazy? That probably happens. I mean, the world of iterations, right? I mean,
I probably asked that question more than it's asked of me, because there's some pretty strange ideas out there that people bring forward.
Yeah, I mean, and I didn't mean it as a slight to you or something. I mean, everybody in designing everything doesn't always think of everything, but of course, when you've done it for 20 or 30 or 40 years, that makes a big difference in it. But I'm certain, like I said, there's iterations that are going back and forth. It would be fun if everything just worked first time, right?
Sometimes it does.
Yeah, that's neat.
And nowadays, and I'm not talking just for myself, for the product I develop, but for any of the major OEMs. Everyone, we're a very mature industry, and those that have been in it a long time have a great historical reference of how things have evolved, and to get to a premium product for any company these days, you arrive at it pretty quickly. There's no second guessing. Like, when I was working out on tour when there were still 50% of the drivers were persimmon, the other 50 were steel. And so that evolution from persimmon to steel, as I came off tour and found myself working in R&D, the first drivers that I worked on were steel drivers, and it was all about shaping and guesswork on what you need to do with wall thicknesses and your center of gravity. We really didn't know where our center of gravities were back in 1990.
You hadn't been there, yeah.
No. And as we evolved from steel to titanium, just by sheer virtue of the head volume increasing, we started developing these much more forgiving drivers, not because TaylorMade or Callaway or Ping or anybody had the intellect on what they were doing. It's just that all of these companies at the same time were just expanding the size of their heads and making them much easier to hit and easier to get the ball airborne. What's really been, as far as my viewpoint in the past decade, the thing that has really advanced driver development is the continuous use of launch monitors in player fittings and capturing the launch condition data that leads to longest hitting drives is just provided R&D departments all the insight they need on what needs to be done to make a better driver. Yeah. And so, just by virtue of fitting players, thousands and thousands of players over the past decade has given all designers the insights they needed to make good equipment today.
That's some really interesting insights. I still remember, there's one guy that I see every year, and I remember the first time I saw him, he always hit this sort of a low, boring shot, right? And it'd sort of rise, but you surely don't see that with those guys. At least that's not what I see. They carry the ball.
The center of gravity of today's heads don't really lead to that.
Yeah,
with his swing that he has.
Yeah. Well, thanks for all that. And it's neat to know that there's such confidence in what people do about how they build these things. That's not a perspective that I had. From a design and head performance standpoint, there's a number of terms people throw around, but maybe the top 3 or 4 terms that you think golfers and club fitters, in terms of definitions, that we need to know, and some of the things that you think matter the most.
Well, some of the things that I think matter the most aren't always the things that the OEMs are touting or that club fitters might not be touting, because it's all from a perspective. Everybody has their own point of view.
Sure.
One of my big, from doing a lot of fitting, both the touring professionals and amateurs, I like to fit to shorter drivers. And so, you get the OEMs to get their driver lengths down to 45 or 44 and a half. That's sacrilegious. You can't go down there. That leads to shorter distances because the robot says so.
Yeah.
But in real world applications, too many golfers, and this is, I've seen this so many times, even when I'm doing the fitting, they've got a launch monitor. It's given them some feedback on their carry distance and total distance, and they're out there looking for the driver that hits it the furthest. And they find one that's like, wow, I got this one 287, and this other one I can only get 275. And they always look at that one number, and I like looking at the entire grouping. I always like working with the visual image that TrackMan or FlightScope provide, as opposed to just looking at the numbers, and look at your consistent distance and dispersion with this driver at 275, and look at the inconsistencies on this one that you hit 287. Yeah, you bombed one out there, but you've got them scattered like shotgun all over the range. And And so there's too much focus on that distance when really it's a combination of consistency or tighter dispersion in distance. And so what is the club that you consistently can rely on? That's really what it boils down to.
Now, from a head design standpoint, are there any particular things that you think help that the most? I mean, some of the ability, for example, to not lose as much distance across the face, maybe one, or any particular things.
Yes, unfortunately, the trending of the industry right now goes against what works the best. And what works the best, and we've known it for years, you've probably heard it touted by companies over the past 20 years, deep low center of gravity for a driver. Mm-hmm. You want to get that CG as rearward from the face as possible and as low as possible. And it's simple physics. The physics of the vertical gear effect that you get, which means you're impacting the ball above the vertical center of gravity and able to launch that low rearward CG, increases that launch angle and reduces the spin. And every manufacturer has known that. However, with adjustable hosels, the ability to get that center of gravity as rearward as it can be isn't occurring. And OEMs are purposefully giving that up for flexibility, so that they can create one driver loft, fit of people from that, and keep their inventory SKUs down. And they've given up potential performance for flexibility at retail from a fitting standpoint and flexibility for inventory management. And I've worked on products that both incorporate the adjustable hosels and that don't. And currently, the latest drivers I've been involved in that don't incorporate an adjustable hosel has allowed us to shift the center of gravity more rearward than any other products on the market. And the moment of inertia goes up, the stability of impacts across the face increases, and the really important thing, when we put it on to Golf Laboratories robot and we start looking at off-center hits, that rearward gravity is just a hands-down winner versus something that's more forward. You might recall a few companies in recent years bringing their center of gravity very forward and say loft it up. Those can hit the ball very far on a center hit on a robot, but as soon as you go off center, the dispersion and the distance loss is incredible.
What a fascinating discussion that was. Thanks for that. And the club fitters listening to this are, I'm sure, taking notes. It's you probably noticed the Jimmy Walker thing. This is a digression but my gosh, I've had 3 or 4 people already email me about, oh my God, can you build me a 42-inch driver? And, I'm not sure that's necessarily the right way to go for everybody, that it's not the magic bullet, right? But
well, the point I like making on driver length is the right now the average consumer driver, if you average it all out, is like 45 3/4 inches. Yeah. But you look out on the tour, these are the best ball strikers in the world. They're right around 44.5 inches.
Oh yeah,
and they need to make money with the tools in their bag, and they know how those tools should be optimized. And a shorter driver length is one of those traits that lead to better performance.
Oh yeah. I very, very infrequently will I build a driver for somebody that's longer than 44.5. Almost never.
Yeah, that's great.
Well,
you just need heads heavy.
That's right. That's right. You got to get the head to the right weight. Well, one of the other things I wanted to talk a little bit too, from a design standpoint. So anything that you design has some constraints, and some of the constraints, I guess, are USGA constraints, but what have been some of the most important constraints that you typically are dealing with in terms of driver head design that you have to pay attention to?
Yeah, well, first of all, mentioning the USGA, I know there's a lot of OEMs that really dislike the constraints the USGA places on our ability to design product. I just look at it as the rules of the game. It's a level playing field. Everybody has to design within the USGA rules. So as long as you're building a USGA conforming product, nobody has advantage over another. It just all boils down to your resources and know-how. Some of the biggest constraints, well, again, what I previously mentioned, taking an adjustable hosel system, using it on a driver when you want to have a really forgiving, stable design. To me, I as the designer am being constrained out of the starting gate for whoever that client is.
Yeah.
And so I've had customers where we've got down into the CAD and we know exactly what we're giving up if we have the hosel system and if we don't. Another constraint is surface area of a driver. And you can take multiple drivers that are 460 cc's, but they could all have a different amount of surface area. And all depending on cavities, steps, whatever embellishments and features that are incorporated into the design, there are times when I'm working with the 460 cc size limit and I'm having difficulty getting down to weight, and there's other times where I've got plenty of weight left over. And not until you actually get into this field and you develop a lot of product, you realize I've got too much surface area on this particular club.
Now, when you say surface area, is that, overall surface area or the surface area of the face, or just to be clear with people?
Just overall surface area.
Yeah, okay.
And so it's a little bit easier to, the simpler that the design is, usually the less surface area you have, and you can be more efficient with that.
Yeah.
But, we don't have plain-looking golf clubs anymore. Everything is jazzed up in numerous ways for a better cosmetic presentation.
Yeah, yeah.
One of the constraints that had gone away, came back, and has gone away again, being able to use carbon fiber. Not that it was back in 2004, 5, and through there, carbon fiber was introduced, and it allowed designers to do things with equipment that hadn't been done before. And then it went away. And as it went away, it was a constraint for quite a few years. And thank goodness, it's back in fashion to use it in head design again. Quite often it's used and you don't even know what's in there. And
I remember it not being talked about for a while when at one point, again, it was something that everybody talked about, right?
Yeah, it was the feature. But now it's, as opposed to the carbon fiber being a feature, it is an element that allows you to get to the performance feature you're looking for. And so it's not a focal point anymore.
I told you before we're going to go over 30 minutes, and we are, and this is fabulous. This has been a great interview. Maybe you've talked about it, and we can go on to the next question, but, any other areas of confusion that in terms of what golfers hear about driver heads and their performance that you haven't touched so far?
Well, there are always going to be confused golfers out there. At the same time, just from my experience of interacting with golfers in general, compared to 25 years ago, today's golf consumer knows a heck of a lot more about the technology, the equipment, the manufacturing processes, the materials, than they did a quarter century ago. And And especially when it comes to fitter, when I first got into this business back in the late 80s, fitters were actually, back then, they were more club makers than fitters. And someone would go to a club maker and say, yeah, I want a set of these built up, and or I want a driver. And the product would get made to the specifications that were deemed necessary. And, the popularity of components and building your own clubs abounded through the 90s. And then the early 2000s, we started seeing a shift, and those that were club makers couldn't compete with the low price of the OEM products at that point in time. And those that were true fitters were either filtered out and left behind, no longer fitting because they weren't sophisticated enough. But the ones that have remained and made it through that, and all the newer ones that have come in since, we're talking about some sophisticated people that use sophisticated equipment like launch monitors and completely understand the physics of what needs to occur in ball flight and what needs to happen to the equipment. So the fitters of today are extremely good compared to 15 years ago. The consumers of today that are smart enough to go to a fitter are playing with product that is hands down better for them than they could ever purchase off a shelf or try to fit themselves with. And so if there's an area of confusion for a consumer out there, I would say find a local fitter and throw that confusion back to them, because they're going to get fit properly. They don't have to be.
Throw the confusion. That's a great choice of words. I like that. Yeah.
Yeah. Today's fitters are great.
Yeah.
So whether you're tied in with a big company or a retailer or you're independent, there's no way you could be a successful fitter today and not be good. Only the good ones are the ones that are surviving.
Yeah. Well, thanks for that. And, those of us who are working hard at doing that, definitely agree with that. Now, I didn't plant this question, but thinking of things you said earlier, but, I did want to talk about, I know you recently designed the Swing Science FC1 driver head. And so I thought that would be a great example to talk about some of the things that you were involved in terms of doing that, maybe things that we hadn't talked about from a design standpoint. And how did that come about as an example of, sort of what you do?
Well, the work I've done for Swing Science has been rather interesting. The way I got to working with them is they had someone doing some product development for them, and they had designed a product, and Swing Science approached me and said, we need this product re-engineered. We like the way it looks, but things need to be done to it because it just doesn't perform. And that was my introduction to working with them, and we got the product to where it performed very, very well for them. Eventually, they said, we need a second generation product, and we want this one to be adjustable as far as the hosel goes. And as with every client, I said, okay, here's the pros and cons.
Right.
And they said, no, we have a network of fitters, and we want to provide them with product that's good for them to fit with. And so in doing so, in developing the FC1 driver, we had a basic shape that was our starting point. And what we had to do through the prototyping process, we worked with a series of internal plates, titanium plates, that were welded to the sole and were able to push the center of gravity rearward on various iterations, while also tweaking with the adjustable hosel system and the loft of the driver. And what we ended up with were various prototype models that were tested not by robot but by scratch
golfers,
humans,
right?
On launch monitors and capturing the pertinent ball flights that we were looking for. One thing that we were looking for is versatility, and because this had to cater to those that want a lower loft and those that need a higher loft, I had to make sure the face design was versatile enough so that it really catered to everyone. What you tend to do in those cases, you tend to go more forgiving through the face, which means the variable face thickness design is not going to be structured necessarily for the tournament golfer. Even though a tournament golfer might be using the product, you need to really design it to accommodate the highest handicapper that's going to be using that product.
Yeah.
And so in that case, the variable face thickness construction leans towards that direction. But we ended up with a CG location that gets the ball up quite well for those that need it at that higher 12 and a half degree loft setting. But we really got a beautiful, boring trajectory for those that are going to need it between 9.5 and 10.5 degrees, where there's that's a sweet spot for a lot of fittings.
Yeah.
And we've got a fairway wood that has been designed to accompany that. Same exact face design on there as far as what we've done from variable face thickness. Also, both the driver and fairway wood have a variable crown thickness. There's actually a honeycomb structure on the interior of the crown. So as with so many drivers today, you look at the outside of it and you don't see the technology. If you were to cut this open, you would see that there are parts of the crown that are just micro thin. But the way that we were able to get those so thin is to put a lattice structure, or more like a honeycomb structure of reinforcement around that, so that we could have that very thin crown and take that weight out of there, which allowed us to play around with the center of gravity. And between going variable thickness on the face and variable thickness on the crown, that provided us enough discretionary weight that got a performance that Swing Science really liked.
Yeah. Now, and you also have a version of the FC1 that's a non-adjustable hosel driver too, right? Talk maybe just a minute about the particular difference.
Yeah, that was the driver that got me working with Swing Science. I cannot take any credit for the actual visual design of that product. All the work that I had done with it is essentially engineering work with the interior.
Oh, okay.
And when I was first approached to work with Swing Science, that driver was in a slightly smaller volume.
Yeah.
We brought it up to 460 cc's. We tried to get it as forgiving as possible. That is the reason there is not an adjustable hosel on it. We did try in earlier engineering iterations of it, add adjustable hosel to that. And to be quite honest, we had some durability issues with the sole because of the adjustable hosel and the way it needed to be constructed. And we knew to gain the most efficiency in performance, we had to kind of toss that aside. And as a result, instead of having one SKU, Swing Science had to move forward with 2 SKUs. But that driver's been very successful for them. They've had it in the line for, I think 4 years now.
Yeah, I've heard a lot of people really talk a lot about that one too. Yeah. Well, very good, Jeff. This has been a fascinating discussion today. Any final words you want to give golfers? Things you just want to reemphasize about drivers and performance or any particular thing maybe you didn't say that you wanted to say?
Get something new. If you're a golfer out there and you got a 10-year-old driver and you say, I don't need any of this new stuff, take a second look, because what we know and put into the engineering of a driver today is tenfold the knowledge that we had 10 years ago. And 10 years ago, we had tenfold the knowledge that we had 10 years prior to that. What we could achieve today with the construction and the durability, allowing us to manipulate the CG and get the face tuned in perfectly, we didn't have that 10 years ago. And so if anybody is out there playing with equipment that goes back into the mid-2000s, it's time to step up and look at getting something that's going to make the game a lot more fun.
Yeah, that's a great way to end. Well, I really, again, appreciate you doing this. I'm hoping you're going to come back and we're going to talk specifically about irons at some point. I'll put some links in the show notes to your website. But I learned a lot today, and I'm hoping that the people that listen to this get some great value from it too. Jeff, thanks a lot. Hang in for just a second afterwards. There's actually one or two things I want to mention to you, but that'll be offline.
Thank you, Tony. It's been my pleasure.
Take care.
www.gameimprovementgolf.com.
Well, thanks, Jeff. I certainly have a much greater appreciation now for what goes into creating all of the terrific modern technology driver heads that are available for golfers to play with. This is actually an interview that I know I'm going to go back and listen to again. To learn more about Jeff Sheets and Jeff Sheets Golf, check out the link to his website in the show notes, and stay tuned for another interview with Jeff in a month or so about iron head design. Well, next week I'm off to the PGA Equipment Show. I'm looking forward, as always, to attending the show, and there's a tremendous amount of things that I get to see and learn about while I'm there. I'm actually going to put a lot of information about what I learned at the PGA Show in my monthly newsletter that comes out on the 15th of the month. The next one will come out on February 15th. If you don't subscribe to that already, you can find out how to do that on my website. Well, that's it for today. In 2 weeks, I'm going to do a series of 2 podcasts with highlights from the podcast interviews that I was so fortunate to get to do with so many great people in 2016. I hope you look forward to that. See you in 2 weeks.
Game Improvement Golf, your source of information and inspiration to become an exceptional golfer now. www.gameimprovementgolf.com